Figure shows a device used to compress wet sand and cement to make concrete blocks. The lever arm rotates about the hinge P at its right-hand end. A force of 30 newtons acts downwards on the left-hand end of the lever arm. The force F of the sand and cement mixture on the plunger acts upwards. Ignore the weight of the lever arm. A. Use the clockwise and anti-clockwise moments about P to calculate the upwards force F, which the mixture exerts on the plunger. The distances are shown on figure. The most important thing in moments questions is to identify the pivot. The pivot is the point where the whole system will rotate about. This is our pivot P. The lever arm will rotate about P under the effect of different forces on it. The 30 newtons force will cause an anti-clockwise moment about the pivot, where the force F on the plunger will cause a clockwise moment about the pivot P. Applying the moment condition of equilibrium, we say that clockwise moment equals anti-clockwise moment. In other words, F1d1 equals F2d2, where F is the force, D is the perpendicular distance to the pivot. The force F of the plunger multiplied by 40 centimeters, which is the distance between the plunger and the pivot. This must equal the 30 newtons times 100 centimeters, which is the distance between the 30 newtons and the pivot. Doing our calculations, this will give us that the force F caused by the mixture equals 75 newtons. Question B. A force acts on pivot P. Calculate this force and state its direction. Let's think about this question again. In the previous step, we applied only one condition of equilibrium, which is net moments equal 0, or as most of the students used to say, the total moment clockwise equals the total moment anti-clockwise. The sum of clockwise moments equals the sum of anti-clockwise moments. Applying this condition, we found that the force applied by the plunger is 75 newtons. But actually there is another condition of equilibrium, which is net force equals 0, or maybe you prefer to say total force upwards equals total force downwards. If we look again at our system, we have 30 newtons downwards and what we calculated as 75 newtons upwards. This is not equilibrium because the total force up does not equal the total force down. This means that there is an extra force that is not mentioned in the question. This force is always at the pivot because it has no moments. In our case, it equals 45 newtons and it's downwards. Only now we can say that the total force upwards equals the total force downwards, and both the conditions of equilibrium are applied. So to answer this question, we will say 75 newtons minus 30 newtons. This means that the force that acts on the pivot is 45 newtons and its direction is downwards.